Write a cubic polynomial with roots at x equals -2, -1/3, and 2 with a constant term of -8. Okay, so the first step to solving this problem is going to be to determine the factors corresponding to these roots. So we're going to take each root and try to get 0 on one side of the equals sign. So in this case, for the root at -2, we can add 2 to both sides to leave us with x plus 2 equals 0. So the corresponding factor is x plus 2. Okay, for the root at -1/3, we have x equals -1/3. Multiply both sides by 3 to leave us with 3x equals -1. And then we add 1 to both sides to leave us with 3x plus 1 equals 0. And so our corresponding factor is 3x plus 1. Next, we look at the factor corresponding to the root at x equals 2. So if we subtract 2 from both sides, we end up with x minus 2 equals 0. So the factor that corresponds to that root is x minus 2. Now we have to multiply all of these factors together to get an expanded form polynomial with these roots. And then after that, we'll check to make sure that the constant terms match, or maybe multiply through by some numeric factor to make sure that they do match. Okay, so how about we start by multiplying x plus 2 and x minus 2. So I'll write x plus 2 times x minus 2 times 3x plus 1. X plus 2 times x minus 2 you may recognize as the factored form of a difference of squares. So we can expand it quite easily as x squared minus 4. Hopefully you're familiar with how that works because it saves us some time. Okay, now we multiply this expression by 3x plus 1. So 3x, or maybe I'll go from left to right. We'll use the FOIL method actually. So we'll do the first terms, x squared times 3x. That'll give us 3x cubed. Then we do the outer terms, x squared times 1. That gives us x squared. Then we do the inner terms, -4 times 3x gives us -12x. And finally the last terms, -4 times 1 gives us -4. So here we have an expanded polynomial with the specified roots at -2, -1/3, and 2. However, it doesn't have a constant term of -8. Its constant term is -4. So to give it a constant term of -8, we have to multiply through by a factor of 2. So if I put a 2 here, a 2 here, and a 2 here, we'll end up with 6x cubed plus 2x squared minus 24x minus 8. And that is the polynomial that we're looking for. It's a cubic polynomial with the specified roots, as you can see from the factored form, and a constant term of -8.